This is the grid, feeding a world hungry for power. 100 years ago, relatively few people on this planet had ever even seen a light bulb. Now, and in the blink of an eye, historically speaking, electricity has enabled a new standard of living for humankind, superseding even fire as the element most essential for our quality of life. A new modern and global society continues to emerge and evolve, united in its appetite for more power. But even as the grid expands into the furthest reaches of our environment, the demand for power continues to increase at a staggering rate, putting stresses on an already overtaxed and antiquated network of wires. Across the globe, a great disparity has emerged. As the modern electrified world forges ahead, many poor and remote regions of the world struggle to keep up, and every country on the globe must employ tactics to curb energy consumption for a demanding population. Rolling blackouts are routine in some regions of the world and mean there are more hours in the day without electricity than there are with it. Poor infrastructure and an ever-increasing burden can stress the grid to the absolute limits, sometimes resulting in catastrophic failure. While every country in the world struggles to meet the demand for electricity, there are vast remote regions throughout the world without access to the grid. The International Energy Agency estimates that 1.5 billion people lack access to electricity, more than 1/5 of the world's population. Some 85% of those without electricity live in rural areas, mainly in sub-Saharan Africa and South Asia. Wherever modern humans venture on this planet, they require electricity. Cell phone towers, science stations, early warning systems. These remote outposts must frequently rely on alternative forms of generating electricity in order to function. Wind and solar power either augment or provide all of the energy required. Wind and solar power are good forms of renewable energy, but cannot generate energy on demand. Sometimes, however, humankind ventures where fewer and fewer options are available. The depths of the ocean, for example, the edge of space, the surface of Mars. Neah Power has developed a revolutionary form of fuel cell technology designed for defense, commercial, and consumer applications, which can also be deployed into the world's most remote regions. This is the patented, award-winning PowerChip. Built using traditional computer chip manufacturing methods, it is designed to be deployed on the battlefield and is equally suited for commercial and consumer applications. For the equivalent weight in batteries, the PowerChip fuel cell could significantly extend the range of a mission or dramatically reduce equipment weight for shorter missions. The PowerChip fuel cell acts like an instantly rechargeable battery. When the charge is depleted, the user simply swaps out the old fuel cartridge for a new one and has a fully charged system. Unlike other incumbent fuel cells, the PowerChip also operates in the absence of air, making it a suitable candidate for operation in the vacuum of space, or even at the depths of the ocean. This disruptive product is the culmination of over $50 million of investment from Intel Capital, Novellus Systems, Fraser Ventures, and other investors. Neah Power's patented fuel cell technology is both capital efficient and cost-effective. The PowerChip is made in America at Neah Power's factory located in Bothell, Washington. The processes employed for this unique application have been used in the semiconductor industry for over 3 decades. Neah Power's novel application uses fully depreciated computer chip manufacturing equipment that is several generations older than the cutting-edge equipment used in the fabrication of today's electronic devices. As an added benefit of using older fabrication equipment, Neah Power can get high volumes from foundry suppliers and is thus not limited by capacity constraints as demand grows. Most of us are familiar with Moore's law, which notes that computing capacity effectively doubles every 18 months through scale, efficiency, and miniaturization. As consumers, We benefit from this by an increase in computer power at an ever-decreasing cost, as evidenced by semiconductor chips, flat panel displays, as well as photovoltaic solar panels. Neah Power believes Moore's law can apply to the portable power industry as well. The PowerChip consists of 2 electrodes, an anode and a cathode, which are coated with proprietary materials. These electrodes have a very high surface area as a result of manufacturing techniques applied. These electrodes are assembled into a cell. The fuel flows through the anode and the oxygen-bearing liquid flows by the cathode. Chemical reactions occur on the surface of the electrodes, breaking apart the fuel and oxidant into their constituents, as well as electrons, which generate the electricity. Small off-the-shelf pumps are used to move the fuel and oxidant, which are contained in soft, durable bags inside the cartridge. The PowerChip can generate up to 180 milliwatts per square centimeter, which is significant when compared to the next best alternatives, whether batteries or fuel cells, and can operate with or without the presence of air. The cells can be manufactured in a variety of shapes and sizes and can be stacked together in order to meet more stringent power requirements. Neah Power fuel cells can provide power for applications in the low watt range and for those up to 4 kilowatts. This makes the PowerChip ideally suited for compact portable power like dismounted soldier power or fixed off-the-grid installations, such as streetlights for off-grid locations, a remote cell phone tower or border monitoring station, or an early warning system for natural disasters. Neah Power has already shipped its PowerChip product to a Fortune 150 defense supplier in the United States for evaluation and customization for soldier power, unmanned aerial and underwater applications, and other off-grid solutions. Neah Power is also deploying some of the unique processing techniques of the PowerChip technology with a new architecture for compact, portable applications in the consumer market. Slated for release in the spring of 2013, Neah Power's PowerPlay fuel cell is a lightweight, portable recharger designed for cell phones, smartphones, tablets, or just about any portable consumer device. The PowerPlay features a small fuel cell without any of the pumps or moving parts found in Neah Power's larger PowerChip products. Small interchangeable and refillable cartridges provide the fuel. Each cartridge can supply enough power to fully charge a typical smartphone up to 4 times. We believe the PowerChip and PowerPlay products we are developing provide a bold new solution to the challenges that face us as we push beyond the grid. We invite you to learn more about Neah Power Systems, PowerChip products, and PowerPlay products at www.neahpower.com.